So now I want to talk about rates and slopes. So a rate or a ratio is a fraction, okay? And it shows us how one variable changes with respect to another. And that is what a slope is. Okay, so sometimes these rates or these ratios we'll call an average rate or an average rate of change. So if you see the word average in front, it means just the same thing. This average rate, how does the y change with respect to the x? Okay, so in life, you will often recognize a rate by the word per, P-E-R. So it's in miles per hour, miles per gallon, dollars per hour, right? Maybe you're familiar with some of those. So when we make our ratios, the word before per goes on top of the fraction, and the word after goes on the bottom. Okay? So here's an example. If I want to know the miles per gallon, and sometimes the word mileage goes in place for miles per gallon. So if I want to know the miles per gallon that my car gets, here's what I know. I can drive 400 miles, actually it's a little bit more, on about 8.5 gallons of gas. So that ratio would be, so it's miles per gallon. So on top, right, miles goes on top because it's before per, so 400. And we're going to go ahead and write the units because it'll just be helpful for later. So 400 miles per 8.5 gallons of gas. Right, so that's my ratio. And then we'll either reduce the fraction or we'll find a decimal approximation. So I'm going to go ahead and do a decimal approximation. I'm going to grab my calculator, which I know you guys can't see here, which is totally obnoxious, but sorry. So 400 divided by 8.5. So that's about 47.06 is what we would say. 47.06. No, we wouldn't. We'd say 47, wouldn't we? 47 miles per gallon. So especially with car examples, that per becomes just a P. And right, it's kind of the way we abbreviate those things. So let's find these four rates. So Tom can do 21 math questions in 30 minutes. Find his rate in questions per minute. Okay, so questions on top, right? So it's questions per minute. So it's 21 questions in 30 minutes. And then if you want to use your calculator, that actually looks like it reduces pretty well. I'm going to go ahead and reduce it because I'll use my calculator. I know I'm being lazy. So 21 divided by 30, 0.7. So he can do 0.7 questions per minute. Notice even when I'm reading it off, I take that division line and I read it as per. Okay, Carrie can bike 12 miles in 2 hours and 20 minutes. Find her rate in miles per hour. So I want miles per hour. Oh, this has an extra little thing. I need to change 2 hours and 20 minutes into hours. Okay, so I'm going to do 12 miles already. 2 hours and 20 minutes. So 20 minutes is a third of an hour. So 2 1/3 on bottom. Yikes. Okay, that doesn't look nice. I guess I'm going to do a little fraction math for you guys. So it's 12 divided by 2 1/3. I'm going to, right, so that's 12 divided by 2 1/3. 12 divided by, I'm going to change my 2 1/3 into an improper fraction. So 6 plus 1 is 7/3. And then dividing fractions, you flip the second and multiply. So 12 times 3/7. Stick a 1 under the 12. 36/7. Oh, for goodness sakes, 36/7. And now I'm going to use my calculator. Miles per hour. I'm going to get a decimal version because that's just not something we would say. 36 divided by 7. How about 5.1 miles per hour? I would have thought that would have been faster. Okay, maybe she's doing heels. Okay, let's go. Small hose can fill a pool in 6 hours. Find the rate of filling the pool. Find the rate of filling the pool. So it takes 6 hours to fill one pool. Now that one, that's kind of obnoxious, right? But we want to get the pool 100% full. I'm having a hard time with my pool and my full together. Okay, to fill one pool. So how much of it gets filled per hour? Right? How much of the pool gets filled per hour? So it's one pool every 6 hours per 6 hours. So that would be 1/6 of the pool per hour. I guess I should have been circling my answers. There we go. Okay, last one. Yogi can read 30 pages in 45 minutes. How many minutes per page? Okay, so think about the way you're going to write your fraction. Minutes per page. So it's 45 minutes for 30 pages. So how many pages or how many minutes for one page, right, for each page? So we'd just do that division. So 45 divided by 30, 1.5 minutes per page. Okay, so slope, it's also another name for the rate. So slope, so thinking back to right, something you've probably heard, slope is rise over run. So by rise, what we mean is the change in the y direction, the change in the vertical direction. Run, change in the horizontal direction or the x direction. So what the formula looks like is this. Y sub m, so we use the letter m for slope. M equals y sub 2 minus y sub 1. So that's your rise. How far does it change in the y direction? Divided by the run. How much does it change in the x direction? Okay, so x sub 2 minus x sub 1. So in math, we always look at our graphs when we have them. We always look left to right in the direction of increasing x values. Positive slopes will rise to the right. So positive goes up as you move left to right. Negative slopes go down left to right. And it's just a quick check to make sure that you have done your subtracting right. Okay. So let's go ahead and practice real quick. Just decide if these slopes here are positive or negative. So are you, and one way that you can think about it is, go ahead and put a stick figure on there. And are you walking uphill or are you walking downhill? Okay, and you're always walking left to right. Right, so the first one, right, is definitely positive, walking uphill. Next one is negative. Right, another negative. And exactly, positive. So if you have your points, it's just right a good check to make sure that you haven't right messed up your subtraction. So we're going to go ahead and use the slope formula to find the slope between these pairs of points. So slope formula one more time. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2, and it doesn't matter, pick whichever one you want. Usually if I just need to pick something, I'll put the biggest y value as y sub 2, but it really doesn't matter. The positives and negatives will work themselves out in the math here. So y sub 2 is 8, minus y sub 1 is 1, and then x is on the bottom. So since I started with 8, I have to start with a 5. So 5 minus 3. So 8 minus 1 is 7. 5 minus 3 is 2. So 7/2. Next one, m equals, and if you want to pause at any time and try these on your own, go ahead and come back in and see if you got the same thing. So 7 minus 2, change in y's on top. Change in x's on bottom, so 0 minus -3. So remember, minus a negative plus a positive. So I have 7 minus 2, that's 5. And 0 minus negative, or 0 plus 3, is 3, 5/3. Okay. So again, I could check just real quick. It's going to be totally rough, but 3, 1 is there. 5, 8, right, is up here somewhere. That's increasing. It's positive, and my 7/2 is positive. So that's good. So right here, this is a step of, oh, I went way too far out, didn't I? Sorry. This is a step of 7 up, and pretend that's just two big ones, 2 big steps across. Okay. For this one, 0, 7, and -3, 2. Again, going up to the right. Here's your rise of 5 and your run of 3. Okay. So last one, m equals, so change in y's. Oh, none of that looks good. I'll just go ahead and go here. -4 minus -3. Okay. Start with a -4, so I keep with a -1. Minus 8. Yikes. -4 minus -3 plus a positive. -4 plus 3 is -1. -1 minus 8 is -9. Negative divided by a negative makes both of those positive, 1/9. Okay. Now, let's go ahead and practice. What happens if we have a graph and we need to find the slope? So I'm going to go ahead and just grab a couple of points that I can see. So it looks like those are each by 1. I know it's kind of hard to see. So there's 0, 4. And how about, oh, here's one right here. 2, 3. So the slope, so it's negative. And so rise. So it's rise, but it's actually going down, right? So we're going down 1. So I'm going to make that -1, change in the y's. And then run, that's a run of 2. So I can just count it off from the graph. Could also write down the coordinates of the point, use the formula, but I didn't have to this time because I could see where those are and count them off. Okay, so let's try it on this next one. Grab 2 points where it looks like it's crossing pretty well. It looks like it's crossing there and maybe here. Okay. So this is going to be a positive one. So let's see, how far do we go up? We go up 1, 2, 3, 4. And then we run 1, 2, 3. Positive 4/3. Okay, finally, if you have horizontal or vertical lines and you want to describe the slope, horizontal lines have a slope of 0, right? Completely flat. And that would also hold true, right, if you did the formula. So what you would have is you would have the same y value. So when you subtracted, right, y1 and y2 would be equal. So you'd have 0 over some number. That's a 0. Vertical lines, so sorry, horizontal go this way, vertical go this way. Vertical or up and down. Vertical lines have a slope that is, we say, undefined. And if you try to use the formula, what's going to happen is you're going to get a 0 in the denominator. And zeros in the denominator are undefined. We don't divide by 0. So horizontal lines, right, flat, you're not walking uphill or downhill. Slope is 0. Vertical lines, slope is undefined, right? You can't walk on that line at all.